Hey guys, it's time for a short update again. This time for the RetroARDUInput. I worked on the hardware a little bit in the background. On the software I tried, but without success so far. What is upcoming, you will learn after the intro. Short after the introduction video to the RetroARDUInput, I built two more devices. One of them, as a thanks for the inspiration, went to Adrian's digital basement. While assembling the other two devices, I ran into some strange issues. I communicated these to Adrian, listen yourself, in his mail call video.
Now Volker says here that it seems like some things are not quite working yet, ADB and PS2 mouse support. There's also the culprit that I have not been able to source perfectly working USB host shields for the Arduino in Germany since longer, so for a long time. I wonder what's causing that. That's interesting. I didn't know that. The bug will need you to power the Arduino via USB via a source that is limited to 500 milliamps or lower, which will cause the internal 5 volts to slightly collapse to around 4.5 to 4.7, which then it suddenly works. What?
And I think Adrian's "what" describes the situation quite well. I will try to show you what's going on. On the screen of my laptop you can see the debug outputs. This is my perfectly working #1 prototype. No matter if it's solely running on USB or if I plug in an additional power supply. You will always get feedback from the USB hit. Let's swap prototype 1 against one of my two replications. Sorry, I forgot to put the debug output window in full screen. Please look in the upper left corner. As you can see, only connected to USB, we get inputs. Now let's connect an additional power supply. And as you can see, no more inputs. Let's disconnect the power supply again, and after waiting some seconds, we get inputs again. The root cause can only be the USB host shield. This doesn't work from the factory anyway, as you first need to set the solder jumper bridges. This makes total sense. This configuration is for the Mega 2560, while for other Arduinos it could be different. Let's have a look at the schematic for the Arduino. If the Arduino is only connected to USB, it will get the supply voltage from there. As soon as a power supply is connected that delivers more than 7 volt, this will be detected by a comparator, which will switch over to a power regulator that is generating 5 volt out of the 7 to 12 volt from the input. And now we take into account that the power supply should be totally capable of running the massive lighting in the front and my circuit that is totally full of beginner's mistakes, but for a USB port with 500 mA limitation, this could be a totally different thing. Voltage can easily drop to 4.5 volts then. And it turned out, on the faulty USB host shield, some strange voltage built up on the signal pins. With a stable 5 volt supply, this exceeded the switch level between high and low. When supply drops to 4.5 volt, it stays below the high threshold. I have replicated this using the plus 5 volt pin, which can not only provide power but also take, and supplying once 4.5 and once 5 volts to it. If you are doing so, you should know what you are doing, because not every Uno or Mega revision has a protection diode which prevents feedback to the USB plug. In my case it was fine. In other cases you could damage your USB port on your PC. The idea for a potential workaround was born. On defective host shields, we leave the 3.3 and 5 volt VBus power jumper both open, supply Arduino and host shield with 4.5 volt, and supply stable 5 volt USB power to the test point marked with an arrow. I was also quite unsatisfied with another thing, which is the recessed sitting USB port due to the position of the host shield. So this let me think about rearranging my future plans, here again from the old video. And what are my future plans for the platform? Level 1, surely make it fully working. Level 2, build a modular version, the RetroARDUInput Modular. Level 3, migrate to new platforms like Arduino Duo or Raspberry Pi with Piduino. Level 4, the Retro KV Gem, meaning keyboard, video, joystick, audio and mouse. So let's start with the RetroARDUInput Modular. Let's start with the mainboard. This has a hopelessly oversized power supply, once for 5 volt, and one time you can regulate it. Also on board slots for the CPU board and keyboard, joystick and mouse module. And here's the CPU board for the Arduino. This can provide 5 volts and regulated voltage to the Arduino and the host shield, and also stable 5 volt for the USB port. One side is made up for the host shield and the other side holds the Arduino Mega 2560. Something prepared for the future, the Raspberry Pi board. I was already in contact with Alan, aka Deco Newcomb, the maker of USB 4VC. His project is built on Raspberry Pi and he would like it if I adapt his source code to mine. As space is limited in height, we don't have all mouse boards on one board anymore. One board I called the multi-era PC board, which hosts Serial and PS2. The other board holds Serial and Commodore and Atari mouse. This combination can be particularly useful for owners of an Amiga 2000 with PC Bridgeboard. For keyboard support, all as usual with PC XT, PC 80, PS2, Amiga and Tandy, as well as Apple ADB, which also supports the Apple mouse. This joystick board uses the same DS18030 digital potentiometers as the original RetroARDUInput, so it's totally compatible to the original firmware. Considered here the different pin outs for Tandy and the Acorn BBC Micro. This board has the same purpose but requires a new firmware. Instead of the DS18030 I²C potentiometers, it uses MCP41100 SPI potentiometers. It's marginally cheaper than the DS18030 version, but the price is not the reason I made it. The real reason is this chip grave, which would be extremely expensive using the DS18030. The two cards should be interchangeable without refreshing the firmware. Besides of having a C64, Amiga and Atari digital joystick port, this bad boy also supports pedal support. The C64 requires potentiometers up to 500 kilo ohms for the pedals, some Ataris even 1 mega ohm. As such values don't exist for digital potentiometers, you need to cascade them. The pedal port also can emulate the 1351 proportional mouse for the C64. And as you might wonder what takes so long, here a little bit behind the scenes. The first try of the mainboard consisted mainly of ground plane, which sucked up all the heat and was impossible to solder. Dry solder joints everywhere. Regarding the CPU board, the USB host shield was still sitting a little bit too recessed. It had to move to the front quite a lot, otherwise it looks quite good. For the Raspberry Pi CPU board, the holes for the standing USB connectors didn't fit. I adapted them to hopefully fit any existing USB connector on the market. And the first try of the keyboard module was a perfect failure. For the big DIN connector, for XT, AT, Amiga and Tandy, everything is alright. But look what happened for the two mini DIN for ADB and PS2. In addition, there are some availability issues for some parts. But my goal is to have everything built and tested by mid of the year, which then I will publish to GitHub and announce with a video here on YouTube. So stay tuned, subscribe to the channel to not miss any video, despite or because of the irregular publishing frequency here on this channel. See you next time.